Hello, my name is Jackson. Thank you all for being out here today. I'm very excited to share with y'all a little bit about my journey through CRT. Um, when I was first introduced to CRT, I was at a point where I was very confused about what I wanted to do, start a career in. I had a lot of different interests, a lot of different things that I liked doing, but the idea of like picking one thing to pursue a career in was very daunting for me.
Mm.
Luckily, CRT proved to be a wonderful place to explore all of those interests and really helped me narrow down some things that I didn't really enjoy doing that I thought I might have liked doing, but also highlight things that I definitely really enjoy doing. And it was just a great space to experiment and ultimately figure out, what I might actually, be bearable to start a career in, and you just explore options for the future. And one thing that really stuck out to me was a call it theme that started to emerge through all of the projects that I was doing in CRT. One thing that I was really putting the majority of my time and energy into, and I've summarized it really neatly here as bridging human interaction and system level programming. But I will break that down for y'all. And what I really mean by this is the intersection of two sometimes opposing ideas, and those are the discipline of human interaction design and system level programming. Um, those many in CRT will be familiar. Human interaction design is the discipline of designing technology to be more efficient, um, accessible, and interesting for people. And system level programming is about the opposite of that. It is a subdiscipline of programming that is uniquely involved in the very lowest level, most fundamental inner workings of a computer. And because the focus of system level programming is on efficiency and complete control over the hardware, it oftentimes lacks the tools and abstractions that other kinds of programming have that make human interaction design easier. And because of the difficulty of system level programming, I think it's even an even more important target for the application of thoughtful human interaction design. And I have a couple projects here throughout my time in CRT that I think really drive that point home. This is Pixel Sky. This is a pixel board that connects to the internet and pulls down weather information and displays a couple key facts about the upcoming day. This was my final project for 101, and I consider it to be my first encounter of this idea of system level human design. There's no user input on this device, so the exploration of the relationship between user and device is really specific to just it's a very one-way relationship. But the question I had to ask myself was how I could make this something that just displays numbers interesting in a way that supports its function. And so this is a GIF of my device working. Um, as you can see, what I've done is instead of just having different numbers that instantly change to different key facts, I've put all of the different statuses on a series of animated panes that I could have programmatically slide in front of each other. And the effect that this has is it creates a sense of dynamicism. So there's some movement that draws your eyes towards the piece. Um, it the idea that like their panes that are coming over in front of each other give the whole design a sense of realism. So it just turns from like a black box that shows numbers into something like, yeah, this kind of seems real, like real panes sliding in front of each other. But one thing that I think really elevates this whole design is this border that I added around the side that actually shows how much time is left in the current pane. And the effect that this has is it eliminates all dead time. So I was trying to avoid having any moment of time where this was completely still, completely static. And like the panes, it draws your eyes towards the piece, but it also never looks dead. This also has the effect of eliminating the kind of microseconds of boredom you get for just waiting for the next number to come up. Because if you're looking, I want to know the time, but it's showing me the temperature. It there's like just a tiny bit of boredom, and now you actually have an easier time actually looking at it and waiting for your number to come up. This is OmniWeather. This is also weather related, could be considered a spiritual successor. This also connects to the internet. It's like a little handheld, on the go weather forecast system. It's battery powered. It's got two little buttons on the front and an OLED screen, and can display an entire week's worth of weather forecasts. And because there's user input here, there was a greater opportunity to explore the relationship between user inputs and what's actually happening on the screen. And I wanted to focus on and enunciate the sense of user control that the user has when they use the device. So this is a GIF of this actually working. As you can see, what I've done is each day is given its own little tile, and the user is able to scroll through all the tiles to see all the different days. The smoothness of the scrolling has the effect of reinforcing the actions that the user is taking and actually what's happening on screen. It turns out that whenever text would like jump instantly, or if I was like moving through completely separate screens, there wasn't a great, it didn't feel good. Like the user you would press the right button and things would instantly change. And there wasn't a great mental connection between what the user was actually doing and the results that were taking place on the screen. But with the scrolling, there's like a nice smooth mental connection between those actions. Additionally, as the user scrolls through, one tile is always like focused. And so when a tile is focused, it actually expands to accommodate more information and also shifts over to the right. The effect that this has is it creates the idea of like actually doing something tangible in real life, like flipping through files or going through pages. And it allows the user to relate the action, pressing the buttons, to doing something in real life, which further strengthens the mental connection between what they're doing and what's happening on screen by relating it to something in the real world. This is Lamp Library. This is an Arduino library that I wrote for CRT 101. The goal of Lamp Library was to enable non-coders to create very basic interactive prototypes with sensors, buttons, and LEDs. And these are actually, this is a collage of user projects that were powered with Lamp Library last semester. Designing Lamp Library was really interesting because there was this idea of designing for designers. And what I mean by that is the designers obviously are the 101 students, the ones creating the product, but I'm not designing for the end user. I'm designing a tool to be used by designers. And so as I was going through the process of creating this, I had to almost accommodate two completely separate user groups. I had to consider how will my choices affect the very final outcome, but also how will my design choices improve the experience of the one doing the designing. So there was kind of a Goldilocks zone between like adding complexity and adding cool features that I think would be really cool, but also considering, does the addition of these features make the product overall more difficult to understand? These are two example pieces of code from the Arduino IDE. These are equivalent pieces of code. What this does is it allows you to press a button and it turns on the entire NeoPixel strip on like a toggle. So you press it, turns it on, press it, turns it on. On the right here, this is how you would write this code just in normal Arduino code. But on the left is how you're able to do it using the LAMP library. And so, as you can see, I was able to abstract away a lot of the scariness and the complexity so that the 101 students are able to focus on the pure prototyping aspect of the project, and they don't have to focus on the programming, which is not really the learning objectives of that project. This is SSFP, the Secure Simple Form Protocol. This is my capstone project. It is a lightweight application layer internet protocol for requesting and submitting forms. I'll break that down a little bit because that's a mouthful. An internet protocol, for those unaware, is it defines the rules of engagement for communication over the internet. So they have to be very specific and very all-encompassing, like edge cases, things, how different clients and devices should react when things go wrong. They have to be extremely specific so that all of the devices that use it talk to each other in the exact same way. This is the reason why if you open like Firefox browser or like Chrome browser or like Microsoft Edge, you can visit the exact same website and they'll all work perfectly flawlessly with the same web server because they're all talking in the exact same way. And modern protocols are very complex, and for a good reason, because they need to incorporate all of these edge cases and all of these features, or these use cases. But there are few alternatives that focus on minimalism. And there are some niche applications where you may not want all of the features of, say, HTTPS, but you still want the benefits of standardization, the interoperability between devices and clients. And so there was a small opening there for creating a protocol that had a very small feature set, but was able to run with a fraction of the computational overhead of some of these more modern protocols. In specific, I wanted to target just the user form functionality of HTML, like over HTTPS. So I wanted this protocol to enable clients to send and receive a very small, lightweight, just form description, and then be able to like send that back to servers, all in a secure way. This is an example of the SSFP format. This is a file format I created to describe user forms. So on the left here, you can see that's the text that's representing this form in rendered view. So we have like status messages, we have text fields, we have option buttons. There's more features in SSFP, but this is just a small example. And these are screenshots of the server and client programs that I wrote. The client is this GUI client was designed for Windows 10, and the server was designed for Linux. This is kind of a screenshot of it running in the command line view. These were both written in the C programming language and designed to just be like as lightweight and minimalistic as possible. So one of my design goals is I wanted this to like actually be intuitive for developers to use. So what I did is I did a small user test where I created some documentation, and I would present this to testees alongside of a example target form. And the objective was for the testees to read the documentation, and I wanted to gauge their ability to recreate the target form only using the documentation that I provided them. And this told me a lot about really about how to write documentation. Um, the results were pretty good. They, but I used the results to validate my design choices in the format itself, but also make a lot of iterations on how I was designing my documentation, how I was like presenting the information. And that iteration was turned into ssfp.info. This is a website that I created to host. Yep, it is currently online. You can go to it right now. It is a website that hosts some information about SSFP, as well as some documentation about the file format and the software that I wrote for it. One of my other design goals was I needed it to actually take less computational power to run than the alternatives. So what I did was I created two example forms that I consider equivalent. On the left here is a form in HTML, and on the right is another one in SSFP. And I used Chrome to access the HTML form, and I used my client to access the SSFP form. And I took some measurements about the network bandwidth, the CPU usage, and the memory requirements of both programs. And so this was the result that I got. As you can see, the SSFP client, was able to see like a 98% memory saving and a 99% saving of CPU percentage. CPU percentage is a bit vague because obviously it's going to be machine dependent. These were just run both on my machine. Obviously, this isn't a completely fair comparison because Chrome has a lot of features that are very nice. It's doing a lot more, but this proves that SSFP is a viable alternative for when those features are not required, which was the objective. The third design goal was that I wanted it to be modernly secure. So up to date with the modern understanding of security. What I did for this was I used documentation from an organization called the Internet Engineering Task Force, which I love that name. It's a real organization. And they actually produce and publish standards for a lot of web protocols that are used today, especially considering like security wise. And I used a lot of their recommendations and best practices to inform my design choices when I built the protocol. I'll go over one specifically that I did use. Part of the protocol uses what's called DANE, or DNS authentication of named entities. What this is, it's an alternative to the traditional certificate authority system that HTTPS uses. And it allows server certificates to be connected. It allows them to be associated with particular DNS names. So you can create a hash of a server certificate and put it into a DNS record, and then clients can use that to validate that the server that they're talking to is the real server. And in that way, you can negate the possibility of like man-in-the-middle attacks. but there are different modes and configurations for Dane, and I use the Internet Engineering Task Force's official documentation to figure out what would be the best use case for SSMP. Future outlook. I don't currently have any jobs lined up yet, but I'm currently seeking employment doing firmware development, which I think will be a great place to express my very technical side, as well as some of these more creative design choice concepts. Thank you guys for being here. Thank you for listening. That's all I got.